Hey, good afternoon. I'm going to see if I can get my face on here so I know what I'm looking at here. Is it going to let me do that? Recording, stop. Maybe it does, maybe it doesn't. I'm not here. All right, well, today it's too beautiful. If you can see me, I'm outside. It's too beautiful to go down to my basement to do this recording. I may be off the camera. I wish I could see myself. I don't know why. But today we're going to talk about galaxies. I know we're almost wrapping this year up. You guys have been great pushing through this difficult situation. And we're coming down the home stretch, only a couple more days of new material and some assessments on the unit. And then we're saying goodbye for the summer. So today we're going to talk about galaxies. This is a short lesson. It's going to be combined with the other videos that I've included in there on constellations, a little historical context about the drinking gourd as the Big Dipper following its stars to the North Star to make the Underground Railroad run. So we're going to continue on with galaxies today. So galaxies, basically, they're billions of stars clustered together. As one astronomer once said, billions and billions of stars. Okay, so when we're talking about galaxies, we're talking about stars like our sun, bigger stars, smaller stars, but billions of stars in one galaxy. And remember, there are thousands upon thousands of galaxies in the universe. And we're just talking about individual galaxies with billions of stars. So you can kind of get a perspective on how big the universe really is and how many stars are actually there. There are three basic shapes of galaxies. There is the spiral galaxy, there is the elliptical galaxy, and then there's something called an irregular galaxy. The irregular galaxy can be any shape outside the spiral and the elliptical. Now, the one that's most important to us is our galaxy, the Milky Way. Typo. Oh, well. The Milky Way galaxy is a spiral galaxy. Kind of looks like a pinwheel. It's 120,000 light years across. Now, by definition, a light year is the amount of distance light travels in a year. Okay, I'm going to repeat that again. It's the amount of distance light travels in a year. Now, a lot of people get confused that light years are a measure of time. They're not. The speed of light, it would take 120,000 years to go from one side of the Milky Way galaxy to the other. That's huge. If you want to put that in perspective, a star on the other side of the galaxy, the light takes 120,000 years to go from that star to our eyes. Now, we probably wouldn't see it from the other side because we have to look through something called the central bulge. And if you see that diagram right over here, you'll see that there's a central bulge in the Milky Way galaxy. And that central bulge is a thicker, more dense populace of stars. And that dense populace of stars, they believe, has a black hole, a significant black hole in the middle of it that's gravitationally holding everything together. Okay? And that central bulge is about 10,000 light years thick. Okay? So from top to bottom, it would take 10,000 years for light to pass from one side to the other. And you can see the conversions there. 1 light year equals about 9.5 trillion kilometers or 5.88 trillion miles. Now, Now, you are here. This is our galaxy. Our sun is just one of the many stars in the solar system, in the Milky Way galaxy. It just happens to be our friend, our local star. We are located about halfway out on one of the spiral arms. So if you look at the diagram to the right, you'll see a picture of the Milky Way galaxy. Now, we only have a couple pictures of the Milky Way galaxy because it's hard to leave the Milky Way galaxy because it's so big and get an actual picture of it. Usually the pictures you'll see of a galaxy will be another galaxy that scientists believe are similar in shape and construction as our galaxy, and we use that to represent our galaxy. So yes, we're halfway out one of the arms, and we're about halfway between the top and the bottom of that arm with regards to stars. The closest nearest star to us is 4.3 light years away, and that's in our own galaxy. So it takes 4.3 years for that light to get here. So Despite the fact that there are a lot of stars, the galaxy is so large that they're still very, very spread out. And I think that's one of the challenges, and we'll talk about that a little bit more in the next class, is how big everything is in space. Okay, our nearest other star is 4.3 light years away. If we were to make our sun the size of a golf ball at that scale, the next nearest star would be 300 miles away, and everything else would be empty space between it. So when we're talking about space in space, those numbers are ridiculously large and kind of unfathomable. So as we go through today and tomorrow, we start talking about the outer limits of the universe and the origin of the universe. It's a little hard to swallow. It's a little bit big, but these are the best answers scientists have at the moment. And my job is to get that information to you as best as possible. So thank you. And until next time, have a good one.